Thank you very much to the organizing committee and also for the MC, that wonderful introduction. I'm very happy to be sharing this stage with colleagues from across different scientific fields. And I'm also happy to hear about the words education, science, research, because that's at the core of becoming more sustainable when it comes to livestock production. I'm an animal scientist. I'm also a researcher, working primarily with dairy cows. So I'm going to talk a little bit about what we have done. And I'm going to try to make a point that if we want to be more sustainable, we need to learn how the animal responds to climate change, heat stress, etc. So what are the challenges? And again, I'm not going to talk too much about the challenges. We all know that there's a lot of pressure, okay, in the context of providing enough feed, not only for human consumption, competition among humans and livestock for crops, but there's also this other major player, climate change, and we heard a little bit about gas emissions. I'm not going to spend a lot of time talking about gas emissions, but it's one of the challenges that we have, okay? So faced with this pressure, okay, I want to emphasize that among those 4 pillars that have been identified in the arid regions as being very important to have a sustainable livestock industry, these 2 are the ones that I think we're still trying to understand. Us in the US, for example, and European countries have done quite a bit of research trying to understand how climate change and especially heat stress is affecting the animal and how management aspects, for example, nutrition, and other aspects related to the environment or management of livestock species can potentially help those animals remain stress-free or with minimal stress, because that's related to animal health and productivity. If we don't understand how the animal responds to high humidity, high temperatures, we're not going to be unable to feed those animals in a way in which is sustainable and at the same time in a way that maintains productivity for that particular livestock species. I understand that in the arid regions in West Africa and the Middle East, small ruminant production is very important. I don't necessarily work with small ruminants, but there's a growth in dairy farming, not only here in the UAE, but also in the arid regions. Just to give you an example, in the US, we also have states that are fairly arid. For example, Arizona. In Arizona, there's between 125 to 175,000 dairy cows, one of the highest states in terms of dairy production in the United States. So the climate is fairly similar to what we would see here in arid regions of the North Africa and the Middle East. So the question is, how do they manage? Okay? And we're talking about very large farms, 2,000 on average, but could go up to 10, 20,000 dairy cows. So this challenge of being in an arid climate, it's not only associated with countries in the Middle East and North Africa, but also in other parts of the world, the United States included. I'm fortunate to be collaborating with my good colleague from Thailand, Professor Incharoen, on a special issue that is addressing different ways or sustainable ways to managing and growing livestock species, including ruminant animals. Methane was mentioned as one of those important aspects of climate change, but it's not the only one. Okay, high temperatures. I'm going to come back to that because historically we put a lot of emphasis on thermal stress on the animal. Use of land, either for growing crops or forage to feed animals versus humans. Bans on certain types of compounds that we use to maintain health antibiotics being the example. So the challenge is, can we find green nutrition strategies to manage livestock in a sustainable manner? And again, there are a lot of things that go into that. I'm going to show you just a few examples of how we try to link science, knowledge about how the animal works, with nutritional management, which is something that we're very interested in my lab. Now, we've been interested in heat stress in animals for a long time. But it wasn't up until recently, at the turn of the 21st century, that really research into how climate change is affecting livestock production started to speed up. Okay, this is a nice review paper, and you can see here the numbers. Again, in terms of the topic, climate change, again, it's a very popular topic across all different livestock species. There are a number of papers that have been published, and again, this is up to 2021. So if you were to do a search in 2025 right now, you will probably see a doubling of the number of scientific papers that have been published in this particular area, and not only in North America and Europe, but potentially other regions of the world, including some of the arid zones here in North Africa and the Middle East. By far, ruminants, again, ruminants just happen to be my favorite livestock species. That's the one that I've worked with throughout my 25 years on faculty. But there's a lot of research in ruminants, and for good reason. Going back to those numbers that I indicated at the beginning, for example, small ruminant production is very important in arid regions. Dairy production is increasing here in the UAE. In Saudi Arabia, there are close to 700,000 dairy cows. Okay, so again, it's a growing industry. And you're going to see more of that type of research as we move on. Again, we talked a little bit we mentioned education, we mentioned knowledge, okay? One of the big questions that we've had for many years is, okay, well, what are the physiological responses or changes in the animal? And I'm going to use the ruminant, the dairy cow in particular, to make a point about all livestock species that experience high temperatures and potentially high humidity. That's not the case here in our regions, but I do a lot of work, for example, in Southeast Asia, Vietnam, Thailand, and in those places, high humidity is a real problem. I'm not going to talk too much about what you see here, but I want to make a couple of points. One of the first responses in an animal that is heat stressed is a reduction in feed intake. Okay, the animal is trying to dissipate heat. A lot of the energy is going towards getting rid of heat so that a normal environment within the body can be reached. So this is obviously not a good thing, because what happens when the animal stops eating? In the case of a dairy cow, the animal is not going to produce as she would if everything was under control conditions. Less milk production, less efficiency. Why? Because nutrients are not going towards producing for example, milk protein, milk fat. Those nutrients have to go elsewhere. And one of the important things that happens in the context of use of nutrients during heat stress is immune activation, meaning the immune response in the animal is also going to be triggered during heat stress, and those nutrients that could have gone to the mammary gland are going to have to go to the immune cells so that the animal can mount a response to try to alleviate the various negative impacts of heat stress. There are two that are very important, and those relate to permeability of the GI tract. In the case of the ruminant, potential issues related to permeability of the ruminal epithelium, but also in the small intestine. And that's important because unlike other livestock species, the front end of the GI tract in a ruminant animal obviously is the rumen, and where there are a lot of microbes that ferment components in the diet. What can happen is, if there's an increase in permeability in the rumen and in the small intestine, molecules that have bioactivity, okay, that's one way in which we refer to some of these molecules, can potentially trigger these events that are going to sequester nutrients that can potentially go to other parts of the body for a productive purpose. So at the moment, there is a lot of interest in trying to understand how can we manage livestock species and dairy cows as an example in the context of preventing a lot of issues related to permeability of the gut, because again, that could create major problems. And one of the ways in we do that, again, not only in my lab, but many labs across the world, is to try to feed them in a way in which we can potentially help them alleviate some of these issues related to heat stress. In fact, any stress can potentially lead to issues related to gut function. I really like this slide because, again, depending on what we're feeding animals, we can potentially enhance certain vitamins that have a bioactive effect against stress. Cells in the body are also able to make certain compounds like glutathione and taurine endogenously. So we can kind of understand how we can enhance some of those pathways through nutrition, which is not an easy thing because, again, whether you're working with a ruminant or a non-ruminant species, whether you're working with a pregnant animal that's not lactating, whether you're working with an animal that's early in lactation versus one that is in late lactation, requirements are likely going to be different. And assessing requirements in ruminants is even more complicated because of the rumen. Okay, so that's another conversation that we can have. But something that we were very interested in trying to do was, okay, if in fact animals that are heat stressed suffer from this pro-oxidant, pro-inflammatory state, can we look at different ways nutritionally to try to alleviate that? This is from research that was performed using heat chambers. One of the ways in which we can do experiments to try to understand the role of heat stress on physiology of the animal is to challenge them with heat, okay? You can do that a couple different ways. This is from a work that was done in Beijing. One of my colleagues at the Key Nutrition Lab in Beijing with access to heat chambers where they can manipulate temperature and humidity. What I wanted to show you was how a very simple nutrient, selenium, okay, whether we feed selenium either in a salt form, which is selenium selenite, it's the most common source of selenium that we feed livestock, or whether we feed it in a complex form with an amino acid, in this case methionine, we can change the bioavailability of that selenium such that absorption of that selenium from the selenium methionine increases selenium not only in milk, again, without changing milk production, we can enhance nutrient supply, and especially nutrients that can have a beneficial effect in terms of the antioxidant capacity of the animal. And again, that's also reflected in the fact that a very potent pro-oxidant compound like hydrogen peroxide was actually decreased, while function of the liver that we can assess with different biomarkers also was enhanced. Okay, so again, this is something that we can do with through nutrition. Of course, selenium, I don't know here in the UAE or in whether in arid regions in the Middle East, whether selenium is regulated when it comes to feeding animals. In the US, it is. Okay, so it's a regulated compound, and of course, depending on whether plants that are fed to animals are growing in selenium deficient or selenium rich soils, you have to take that into account because that will determine how much supplementation you can have. Something else that's also very important in this type of study related to selenium is the fact that, again, when those animals were challenged in these heat chambers for about 9 days, selenium methionine, again, a more bioavailable form, was actually able to enhance or maintain a glutathione peroxidase activity while reducing the production or concentrations of peroxidation products. That is a beneficial effect of this micronutrient, okay? So again, when we're trying to manage dairy cows in particular during heat stress conditions, it doesn't necessarily mean that we want them to enhance production. What we want them is to remain healthy and to produce as they would if they were in conditions that were less stressful from the environmental standpoint. That's a very important point to keep in mind. Now, we have tried to address the antioxidant angle of feeding animals through the supply of methionine. Okay? Methionine is an essential amino acid, not only for ruminant animals, but also for other livestock species. What we tried to do about 15 years ago was to answer the question about methionine and its potential role in synthesizing glutathione and taurine endogenously. What do I mean by that? What we were interested in doing was increasing the supply of methionine. Again, methionine in dairy nutrition is very important because it's one of the top two amino acids that can limit milk production. But we were looking at it at a different angle. We were trying to really show that additional methionine not only could improve milk synthesis, but also potentially the antioxidant capacity in those animals as it relates to stressors, heat stress being one of them. I will make a point that when you look at this complex pathway here, it's not only about methionine, there is a lot of regulatory effects, okay, other micronutrients that can potentially feed into those enzymes. So it's really a complex process. We've done quite a bit of research on methionine. There are other groups that are also trying to challenge cows with heat stress and look at different aspects of the methionine question, protein synthesis being one of them. And what I'm showing you here is really a summary of 3 experiments that have been published. Something that is very interesting beyond milk protein production, which we can see here can be alleviated when we supply rumen-protected methionine to the animal, is the fact that that methionine can also impact the number of mammary cells that are actually active. Okay, so that's an important effect that we were not necessarily aware of. Now, this approach of feeding methionine has also been tested in heat stress environmental conditions. These are data from one of my colleagues in southern Brazil. Again, very hot and very humid. And you can see some potentially important responses in the animal during those summer months. So again, methionine, again, an essential amino acid, potentially having a very important effect. Now, beyond milk production, amino acids are actually functional molecules, meaning that they can be part of different pathways that can potentially enhance gut function. And they do that across different biological processes, including changes in the microbiota in the gut. Okay? I'm not going to go into this, but I'm going to highlight a few amino acids, especially in non-ruminant species. We still have a lot of work to do in ruminants. Again, I showed you a little bit of data with methionine, but potentially there are other amino acids that can also have this functional effect at the level of the GI tract in the ruminant animal, and again, have a beneficial effect in the context of stress. Now, those of you who are unfamiliar with the ruminant animals, one of the big issues with ruminants is that, of course, they ferment and they produce volatile fatty acids in the rumen. Okay, and acid is something that is going to reduce pH. We don't want that for too long, because what can happen is the epithelial barrier in that rumen can potentially start being destroyed. And this is what happens during bouts of heat stress. So if you think about it, under chronic conditions, a prolonged exposure to low feed intake, prolonged exposure to low pH and high acid loads can potentially cause damage of that intestine, that ruminal epithelium lining, which would increase the movement of toxins, bioactive molecules that can potentially have a negative impact on the animal. Now, heat stress is not the only thing that is going to cause these sort of issues. Again, if you underfeed animals, if you feed restrict them, if you overcrowd animals in pens, you can potentially create these problems as well. We've done quite a bit of work in the area of bioinformatics, again, using computers and data sets to try to understand, using published data, potential pathways, okay, that we can target at the level of the epithelium, the rumen, and also in the small intestine to potentially try to alleviate this issue, these negative issues of heat stress. I'm showing you here something that came up in this bioinformatics analysis related to amino acid metabolism. What you see here in red color are a lot of genes, in this case, belonging to several different pathways related to amino acids that were severely affected when cows were heat stressed, okay? And you can go down the list. This is something that we published in 2023. But what we did was we tried to challenge cows using heat blankets. That's an actual cow with a blanket. It's keeping her very hot, okay, because we come from the state of Illinois, which is not a warm state in the US. So just to make a long story short, what we were able to show was after we fed them with rumen-protected methionine, we were able to maintain permeability of the epithelial barrier in the rumen, meaning that that amino acid was actually having a beneficial effect in the context of epithelial function. Now moving into the end of the presentation, and if I can have another minute, the MC calls the shots, so she needs to tell me. So what can we do? I'm telling you about, so rumen-protected methionine, it's an amino acid, an essential amino acid. It's commercially sourced, but are there other ways in which we can potentially use other approaches in terms of nutrition of the animal? Some of you might have heard about insect meals or insect-based feed sources, okay? They have very high protein and lipid content, potentially a very good amino acid profile that we can use in livestock species. I think in poultry are very popular. There are other byproducts that can potentially have a good amount of bioactive molecules that can have a positive effect, okay? So again, depending on what you have available, potentially these are two ways in which we can move forward. Now, my colleagues in Southeast Asia, in Vietnam in particular, have done a lot of work. As you can see here, some examples of agro-industrial byproducts, okay? And they try to use them because not only they have a pretty good profile of micronutrients and fiber, but potentially have not only polyphenols, but other micromolecules that can have a beneficial effect. What about arid regions in North Africa and the Middle East? Well, when I did my research, this is everything that came up as potentially being usable, okay, as supplements in the area of livestock nutrition here in this region. So potentially having access to these, of course, we need to be able to identify components of these different sources, because if we're able to identify not only polyphenols but potentially other bioactive molecules, we can get into the area of nutrigenomics, meaning that a single nutrient, okay, in this case polyphenols, can activate molecular pathways that will have an antioxidant effect, which is a good thing, especially in periods of stress, including high temperatures in the summer, for example. Microalgae, this is a big deal. Not only, when I hear about microalgae in livestock production, I think about California because they're putting a lot of emphasis on that. Why are microalgae important? You can see here microalgae or algae have very important compounds, essential fatty acids, maybe a good amino acid profile, and of course, there's a lot of interest here in the GCC countries in potentially harvesting microalgae to be used in the area of ruminant nutrition. Algae in particular can have an anti-methanogenic effect, so most of that has been focus on that. But again, if we're having an effect at the level of methane synthesis, potentially other compounds in that algae can be having effects that can only be detected by using technology. Okay, and that's where the field of feedomics comes into place. Okay, being able to understand how the animal is responding to these different feed additives, different feed components in the diet using technology. Okay, and again, I'm not going to get into that, but I just want to leave you with these major points. Okay, we can feed animals, dairy cows in particular, and small ruminants in particular, using alternative feed resources that are more sustainable. Again, the key here is to understand what's in these products and what they do at the level of the animal. So going back to the physiology, understanding what those compounds can potentially do and whether they're beneficial or not. With that, I don't know if the MC feels that I have time for a question or not, but thank you for the attention.
Thank you, Dr. Juan, for this very inspiring talk and for shedding the light on some of the green nutrition strategies to really improve the sustainable production of livestock. And it's just impressive to see the power of nutrients, just nutrition, to change that.
That is correct.
Yeah. Thank you so much. If there's, I don't know if there's any question, we will leave the floor only for one question. Yes.
Thank you for your great presentation, which is very important in our region here for heat stress, especially for cows. I want to ask about if you have any details or information about the use of cysteamine hydrochloride as an agent for controlling heat stress when it added for feed. Cysteamine hydrochloride.
Cysteamine hydrochloride. Good
Yes.
question. I have not heard about that particular compound.
This compound is now is a new, but I wanted to ask how if you have any experience about it and how can we introduce it if it is FDA approved for to be added for cows and its effect in milk production.
No, like I said, I don't have experience with that. But what I would say is that we have to be careful with these products as well. If there's not enough literature or research behind it, you probably do not want to use it.
Okay, thank you.
Yeah.
Thank you so much, Dr. Juan, again.
Thank you very much.
Thank you. Let's give a big round of applause.